systems. Okay, accept. On simplified hydroponic systems, which are interesting solutions for urban environment, especially in developing countries, to promote a low-tech horticulture and favor food security, and also eventual creation of small incomes for the families. As Ranka said, I come from the University of Bologna, from the Department of Agricultural and Food Sciences and Technologies. I've been doing research on urban agriculture, on different aspects of urban agriculture, from high-tech solutions to simplified solution that will be the main focus of today's presentation. We will also have later a presentation by Naim Mazarin, which will be presented by Amer Sweity. And Naim is a director, general assistant of research at NARC, and an irrigation water management specialist. Well, I also wanted to introduce you very briefly my research group. I don't know if you can see it. I don't know how to, well, okay, hope you can see. Well, I wanted to show you briefly my research group. We have been doing research on simplified, in general, on urban agriculture, and specifically on simplified hydroponic systems all around the world since decades. Here you can see a recent picture of our research group and some pictures of the application of simplified hydroponic that we've been developing, in this case in Palestine. Later I will show you more pictures on the experiences that my research group had. So, okay, so this is briefly those are briefly the topics that we will go through today. So I will start with a short introduction on soilless cultivation, just to give an explanation on what it is and how it works. Then we will see different typologies of soilless cultivation, and then I will give a focus on simplified hydroponic systems. And later, Amer will show us some practical experiences of soilless cultivation in NARC. And at the end, I will also show you the homework to get the certificate. Well, starting from the introduction on soilless cultivation, we know that traditional cultivation is, of course, developed on soil. Soil is a composition of sand, clay, and silt that contains mineral and organic material. It works, of course, as a support for plants' roots. It helps to retain water and to bring nutrients to the plants. However, this is not the only way, of course, to produce. It is possible to produce also without soil. Soilless cultivation is indeed the cultivation carried out in absence of natural soil and directly on the nutrient solution flowing on the substrate, or with the roots of the plants exposed to the air or sprayed periodically with the nutrient solution. So the queen of this type of system is the nutritive solution, the most important point, which is a mixture of water, nutritive elements dissolved in the water, and of course also oxygen, since also the roots of the plants need to breathe. We can distinguish two different typologies of soilless cultivation. We may cultivate using substrates. In this case, we have the so-called substrate culture. And on the other side, we may have the so-called solution culture or hydroponic. Substrate cultivation consists in having the roots of the plants supported by a growing media, an inert growing media, which could be, for instance, moss, perlite, coconut coir, and many other substrates that I will show you later. And in case of hydroponic, in this case, the roots of the plants are in direct contact with the nutritive solution, and the roots are directly grown or eradicate in the nutrient solution, and could be eventually supported by an inert substrate, but in a smaller measure as compared to substrate culture. The reason why soilless cultivation, the main reason, there are actually many reasons why soilless cultivation is could be very useful, but the main reason is that using soilless cultivation, we can give to the plants exactly what they need in terms of water and nutritive elements. And this is a very important thing, considering that we are living in a world where cultivation resources are getting to an end. So it is very important for these reasons. And there are also other important reasons that I will show you later. Okay, so here now some history on soilless cultivation. I think it is very interesting to know that soilless cultivation is not something modern. It is actually something that has been practiced since years. And we can say that the first example of soilless cultivation is represented by the Hanging Gardens of Babylon from 600 before Christ. I think some of you know the history of these gardens. Basically, they were gardens that were constructed by a Babylon king to help his wife to feel less homesick because she was missing the plants of her homeland. So he constructed this system, and this system was probably based on soilless cultivation because it was integrated on a building. The second example in the history of soilless cultivation comes from the Aztecs, from the 12th century. We know from some sources that the Aztec used the so-called chinampas to cultivate on the water. These chinampas were floating gardens that are still visible in some areas of Central and South America. Here you can see a picture of the late Titicaca, where they still cultivating on these floating highlands constructed by mold and vegetable wastes, organic wastes. Another example of soilless cultivation was reported by Marco Polo in the 13th century, where he stated that he had discovered some floating gardens in Asia. And probably these floating gardens were something similar to what observed here in the picture. We have here a picture of Lake Inle in Myanmar, where you can see a cultivation system on water very similar to the chinampas. And this is somehow also related to aquaponic, of course, because the plants are receiving nutrients from fish wastes in these cases, of course. Going on in the history, in the 14th century, Leonardo da Vinci discovered for the first time that the plants absorb mineral nutrients, but he did not publish his notes. And in the 17th century, Francis Bacon published his Sylva Sylvarum, where he first talked about growing plants without soil. Later, in the 19th century, Julius von Sachs and Wilhelm Knopp developed the technique for soilless cultivation called solution culture. So it was the first example of soilless cultivation. Later, and here we arrive at the 20th century, so to modern history, contemporary history. In 1929, William Frederick Jerick from the University of California started to promote this soilless cultivation to produce agricultural crops, and he was the first one coining the term hydroponic, which comes from the ancient Greek, hydro, which means water, and ponos, which means cultivate. And the first successful example of cultivation using soilless system was in 1930, between 1930 and 1935, where when hydroponic was successfully applied in the Wake Island, which was a rocky atoll in the Pacific, which was used by US as a refueling stop for the Pan American Airlines. And since it was too expensive to bring vegetables from the States, they started to cultivate vegetables on this island, and that was the first successful example of soilless application for production purposes. In 1960, Alan Cooper developed the nutrient film technique, which is a famous technique for soilless cultivation that we will see better later. And in the 70s, Franco Massantini was the first pioneer to apply hydroponic, which we will also see better later. But basically, this is a system where the plants are not using any support. The water is a nutritive solution is directly sprayed on the roots, and it is one of the most efficient ways to save water and nutritive elements. But again, we will see better later. So it is not only about the past of soilless cultivation, there is also a future for this type of cultivation, which may look like scientific fantasy, but it is actually applied by NASA. A lot of research and soilless cultivation is applied by NASA to cultivate in the space and eventually one day on Mars or on the moon. So now let's move to the different typologies of soilless cultivation that we may encounter. Soilless could be actually classified according different standards. We may classify it based on the type of circulation of the nutritive solution, on the cultivation technique, type of cultivation technique, and also on the technological level. So starting from the classification basing on the type of cultivation system and basing on the on the type of circulation of the nutritive solution, we may distinguish an open cycle system and a closed loop system. The open cycle system consists in giving the nutritive solution, but letting it out of the system. So there is not a recycle of the nutritive solution. And this system is normally applied when we cultivate in the plants in cultivation bags. This system is the easier to manage because we are giving the exact amount of water and nutritive solution to the plants, and there is also a lower risk of development of disease because we are not reusing the same nutritive solution. But of course, the issue in this case that we risk to waste nutrients and water, and we may also determine water pollution and soil pollution. On the other side, we have the closed loop system, which is a more efficient system in terms of environmental impact and saving of resources. This is normally applied in cultivation techniques like NFT, which is the nutrient film technique, DVC, which is the deep water culture, and Garaffa SPET system that I will show you later. And in this case, we are recirculating the nutritive solution constantly. So there is a perfect reuse of water and nutritive elements, and of course also reduce pollution and wastes. But in this case, it is harder to manage the nutritive solution, and we will have to check constantly the amount of salts in the nutritive solution. And there is, of course, in this case, also a higher risk of disease development. There is to spread the disease all around the system. The soilless system may also be classified according to the type of cultivation technique. Here, I show you before, we can distinguish the solution culture and or hydroponic and the substrate culture. So the solution culture, we said when we have the roots of the plants directly in contact with the nutritive solution. And here I reported the main typologies of solution culture system. So the nutrient film technique, the floating system, aeroponics, and the deep water culture. On the other side, we have the substrate culture, so cultivation of the plants on an inert substrate, which could be sand or gravel, or we can cultivate with a substrate inside bags, or with the so-called ebb and flow system, or also in pots. And now let's see better what the different typologies of cultivation systems. So the nutrient film technique is a system where the nutritive solution is constantly recirculating. You can see here in the picture, so here the tank with the nutritive solution, and it is constantly recirculated. The plants are positioned in lines, and the roots of these plants are in direct contact with the nutritive solution. This system could be applied mostly for leafy vegetable, but also for plants of higher dimensions, for instance, tomatoes or peppers and so on. Then we have the so-called floating system. In this case, the roots of the plants are constantly immersed in a nutritive solution, in a huge concrete frame, in this case, filled with nutritive solution. In this case, it is very important to have a constant oxygenation of the nutritive solution. And of course, in this case, the typologies of plants that could be mainly cultivated are leafy greens that are not that don't need too much to support, that have a short cycle, and that don't risk to have a rootness. The plants are supported normally on polystyrol slabs that can allow the plants floating. Then we have the aeroponic system that I cited before. So in this case, we have the roots of the plants exposed to the air, and the nutritive solution is directly sprayed on the roots of the plants. So there are nozzles that can spray water which is at vapor level, of course, and the system is very efficient, as I said, in terms of water, quantity of water that we give, but the risk in this case is that we will have an obstruction of the nozzles, and if we don't check constantly that the nozzles are working, we may lose very easily the production, because of course the roots of the plants are totally exposed. And also in this system we can recirculate, of course, the nutritive solution. We can recollect the water in excess and reuse it in the system. Then we have the so-called deep water culture. This system is also very famous and is mainly applied for plants with of big dimensions, or here, for instance, you can see peppers, but also cucumbers, tomatoes, and so on. And there is normally a support. In this case, you can see some expanded clay, and the roots of the plants are immersed in the nutritive solution. There is a unique pot containing the nutritive solution, and also in this case, oxygenation is one of the most important things. So moving on to the cultivation using substrates, so the so-called substrate culture, we said that in this case we may also use sand or gravel bed. Here you can see some examples. So we have this inert substrate, mineral substrate. The nutritive solution is directly given to the plants, and the nutritive solution in excess can be recollected and reused for irrigation and nutrition of the plants. Then we may also cultivate in bags. These bags could be filled with different typologies of substrate, from coconut coir to perlite, vermiculite, and so on. And you can see here that this type of system is normally applied for plants of big dimensions. So it is very common for tomatoes production, but also for strawberries. And also in this case, the nutritive solution can be recollected, or we can manage it to have the exact quantity of nutritive solution to be absorbed by the roots of the plants. Here, another example of bag cultivation using rock wool slabs. This is a cultivation method very common in high-tech greenhouses of Northern Europe, for instance, in the Netherlands, using these cubes that are the Grodan cubes. They are very famous in the horticultural field. And basically the system is the same, so rock wool slabs, and there are pipes and tubes that bring directly water and nutritive solution to each plant. Then we have the so-called ebb and flow system. In this case, the plants, each plant is inside its pot, and the nutritive solution is given by using a fluid system, let's say. So it goes up, the nutritive solution goes up, the plants absorb the nutritive solution by capillarity, and then again the nutritive solution goes down. This is commonly used for production of flowers and ornamental plants. Then we have cultivation in pots. So basically a pot, or as you can see here, recycled bags in plastic filled with a substrate, and each plant is inside the pot. And again, there are tubes and pipes that can bring the nutritive solution to the plants. In case of the substrate culture, so it is very, very important to use an appropriate substrate. Well, the main feature that a good substrate for soilless cultivation should have for soilless cultivation are good water retention and drainage, durability, so degradation resistant. It should not contain, of course, macro and microorganisms. It should not contain also soluble mineral nutrients in order to allow us to give exactly what we want to give, and it should maintain also a high surface. It should not maintain a high surface moisture, and should be also available at the local context. And this is very important in terms, not only in environmental terms, but also in economic terms, of course. And later I will show you some example of locally available substrate that we use in our systems. So very quickly, again, the typology of substrates could be, of course, organic or inorganic. In case of the inorganic substrate, we may better distinguish mineral or inorganic. So the mineral or inorganic substrate could be could come from natural unmodified materials, for instance, sand, tuff, or pumice, or they can come from processed materials like perlite, vermiculite, stone wool, and so on. Then we may also use organic substrates, so for instance, green compost, biochar, coconut fiber, rice hulls, peat, and so on. So now, finally, the classification of soilless system basing on the technological level. Here you can see two pictures of a very high technological soilless cultivation system, and on the other side of a simplified soilless cultivation system. High-tech technology soilless cultivation is applied normally for commercial production. I think some of you already heard about the so-called vertical farms or plant factories. These systems are normally applied in urban and peri-urban context, and are very energivore, so they require a lot of energy, and that's why these systems are normally used for commercial production. On the other side, we have the simplified soilless cultivation system that are normally used for self-production and to creation of small incomes in low-income families and in developing countries. So they could be also applied in urban and peri-urban area, but of course with another purpose, which could be also commercial, but with another dimension. And this system, of course, require a very limited energy. And now I will go a bit deeper on this type of system, which are actually the main focus of today's presentation. So simplified hydroponic systems are very useful, I said it before, because they can allow food security, they can favor food security and also favor the development of small incomes in low-income families. But beside of that, there are also many other reasons why to apply simplified hydroponics in developing countries, where first of all is one of the reasons is related to land accessibility. Indeed, in many countries, there is families could have a low accessibility to the land, and fertile soil could be very limited and not allowing a proper food production. So in this case, soilless cultivation using recycled material, reusing recycled material could be really useful to favor food production. Here you can see two pictures of basically desertic environment where, of course, on-soil cultivation wouldn't be possible without using soilless systems. The simplified hydroponics are also very useful to increase the yield of the plants. This is something general for hydroponic system, but also evident in simplified hydroponics. Here you can see two pictures. On the left, on-soil cultivation, and on the other side, hydroponic cultivation of the same cultivar of lettuce transplanted in the same day. And you can see what's the great difference between the two plants. So a lot of more yield as compared to soil cultivation in hydroponic. Another reason why to use simplified hydroponic system is because, I said it before, we can reduce water consumption and increase water use efficiency. And of course, this is particularly important in realities where water is it's a luxury, let's say, something, a limited resource. On the left, you can see a picture of irrigation, traditional irrigation, let's say, so a lot of water wasted, and on the right side, you can see soilless cultivation with simplified hydroponic, where exactly what plants need, where the water is given according to the plant need, and water in excess can be recollected and reused easily. So in this case, we have perfect water use efficiency. Again, another reason to use simplified hydroponic in some tropical countries is because we can cultivate in any season. So in the dry season, as you can see in the left, you can see some picture of what can happen during the dry season, and on the other side, what can happen during the rainy season. So floods everywhere, and soilless cultivation can save from damage of the cultivation. Another reason to use simplified hydroponic is to reduce also the application of pesticides. Indeed, using soilless system, we can lower the incidence of soil-borne disease, and therefore the use of pesticides. And of course, in soilless system, we don't have the presence of weeds, and we don't have to use herbicides. And this is important in economic terms, of course, and also environmental terms. And then another important thing is that using soilless system, there is a reduction of the risk to have contaminations due to heavy metals, so chemical contaminations, and also biological contaminations, for instance, due to Escherichia coli or other type of bacteria. And now let's see some typologies of simplified cultivation system, which are basically what I showed you before in the higher tech system, but develop reusing recycled materials and low technologies. So in these pictures, you can see a simplified floating system. So in this case, we have a very simple raised bed in wood, covered with a plastic film and filled with nutritive solution, where the plants, as in the system that I showed you before, are floating on a polystyrol slab. And of course, it's not only polystyrol slabs. We may also use other type of support for the plants. These systems are normally used, as I said before, for cultivation of leafy plants, but also you can see here, for instance, cultivation of Raphanus. Here, other examples of support instead of polystyrol slabs. We can use also other materials. We can also recycle, for instance, cups of coffee to cultivate. So depending on the local availability, we may recycle everything basically. Here now we have the so-called simplified substrate system. So in this case, same as before, we have a rice bed, but this time filled with an inert substrate. In this case, they used sand and gravel as a support for the plants. And basically, the idea is the same as the floating system, but the nutritive solution is given manually, in this case, to the plants, and the nutritive solution in excess is recollected using a bucket and, of course, reused later to fertirrigate the plants. Here, some picture, this is, I think, Lima, some picture of kids decorating their cultivation system, just to highlight that this system have also a very important social impact on the society. Let's say in general, these systems are important in environmental terms, in economic terms, and also in social terms, of course. Here, other picture, you can see in these systems that it is possible to cultivate also plants of bigger dimension, not only lettuce or other type of small plants and leafy greens, so tomatoes, carrots, peppers, and so on. And here, another typology, recycling, in this case, plastic bags filled with a substrate, plastic bags, or also plastic boxes. Basically, we can recycle everything to cultivate with these simplified systems. And now we have the Garaffas PET system. This Garaffas PET system is something that was developed by my research group. The term Garaffas PET comes from the Portuguese, because it was developed by my research group during an experience in Brazil. Garaffas means bottle, and PET is the plastic bottle. Indeed, it works reusing recycled plastic bottles. So here the system is actually very simple. It's similar to the nutrient film technique. So we have different lines of plastic bottles filled with a substrate, and we have tube and pipes that can bring the nutritive solution from an upper tank to a lower tank. In this case, what we exploit is the gravity, so there is a very reduced application of energy. The water and nutritive solution is sent to each pipe and recollected and bring back to this lower tank. And then we can bring reduce the nutritive solution and bring it back manually, or eventually using a small pump. This system is actually quite cheap. The cost, the estimated cost is around 7 to 8 euros per meter square, while the system that I showed you before had, so the simplified floating system and the simplified substrate system had a cost around 3 to 5 euros, but this cost can also be furtherly reduced using recycled materials and locally available materials, of course. And the maintenance of and management of this system is also very low, since we are not using a lot of energy, so we can have around 1 to 3 euros per meter square per month of cost. So other pictures here, just to show you better what's a garaffa spet. So bottles filled with a substrate. In this case, the substrate that was used, and it is very interesting, I think, was carbonized rice husk, because it was a material locally available, but since it had to be inert, they had to be carbonized, and it perfectly worked for the production. Here you can see production of lettuce and cucumbers. So again, locally available material could be, for instance, also coconut fiber, depending on our location when we develop these systems. Here are other pictures, and here application of bamboo instead of plastic bottles, again, depending on the local availability. And here a picture with some reporting some of the places where my research group have been developing this type of systems. As you can see, through these years, we have been developing systems all around the world, from Brazil, Peru, Myanmar, Ivory Coast, Palestine, Sahara Desert, and many other countries that are not reported here. And during these years, we have been collecting a lot of data to understand the real application and the real efficiency of this system. So here I just try to summarize some of the main achievements and discoveries that we found out and observed during these years of experience. And well, we found out that around 5 meters square of garden can be enough to feed one adult. These gardens help to increase from 3 to 10 times the vegetable consumption of the families applying these systems. And in Peru, Mauritania, and Namibia, we observe that 100 meters square of this type of gardens are enough to provide a minimum salary to the families. Then we observed that less than 1 liter of water per meter square per day and less than 3 grams of fertilizer per meter square per day are enough to maintain this system. So very limited application of cultivation resources, since, of course, in a closed system, these elements, water and nutrients, are recycled. So that was briefly my introduction on soilless and the simplified soilless system. And now NARC will give some, will show some practical experiences on soilless cultivation. So I think that Amer can start now. Amer, I have the control of the presentation. So when you tell me go on, I will.
Yeah, sure. Thank you, Elisa. Hi, everyone. Good morning. My name is Amer Sweity. I am a researcher at NARC, and on behalf of Dr. Naima Zahre, I will give the talk about the experience of NARC in the field of the soilless system. I apologize if you can hear some noise, because I'm at home, and there will be like some traffic and whatever you can hear. So we will start with the experience of NARC. We have to think about like why we have to go to the soilless system in Jordan in general, or why we decided that we have to take into our account that the following reason. Can you go with the presentation, please? Elisa? No. There is a one slide before.
Okay. I have this one and this one.
Okay, so I will just tell you there
Wait.
is a problem of a water scarcity in Jordan, where the country is considered the poorest country in the world in terms of water resources. The population growth in the last 20 years have pushed the resources to be depleted more, and we are losing our groundwater resources. As also, you know, the climate change is hitting the country so badly, and the droughts are being witnessed everywhere. And also the natural resources also being degraded, which means we have increase in salinity and also increase of other environmental problem, which stated for us, which pushed us to use or to think about some other solutions to save water in the agriculture sector, which is very important for the country in terms of food security and also for fulfilling the demand of the Jordanian people. So we have to think about a traditional way of cultivation our products. We have to go for the protected agriculture. Most of the farmers in Jordan were growing their fields in an open areas. And then they have to start to shift to protected in greenhouses or multi-span greenhouses. Then we have to think about like the smart irrigation techniques by introducing advanced technology to be adapting all of these massive changes that happen in the country. So could you go more, please?
Yeah, sure.
Yeah. So the NARC experience actually, you know, like shifting from a traditional agriculture to soilless agriculture will take time. We started in this process back in 2001. The first experience or the first experiment was conducted by a researcher of NARC and also a researcher from some other Jordanian university on testing the soilless culture on tomato fruits. Could you, for the other one, please? Yeah, so the first one was conducted in Sharhabil research station, which belonged to NARC, where the researcher used three media. These media were containing of tooth, which is a volcanic rock, and also sand and regular soil. So more, please. So you can see that the result that was retrieved from this research showing that the water saving around like 65% to 70% when we were using or applying the soil system on the sand or the tooth compared to the soil. So the water saving was around 65% to 70%. There was also no change in the food quality or the yield quality and the quantity, which means that we succeeded to at least to save the scarce commodity for our country. And also it will decrease the burden on the farmers to save the prices of the water for them. And also we have to think about like the diseases. There was no diseases. Everything was controlled. And the problem at that time, the heat was just exaggerated in the area. You know, Bashar Habil is located in the Jordan Valley. The temperature is really hot during the summer, moderate during the winter. And it means the soilless system was suffering from, let's say, the heat issues, and we have to think about the cooling. Then at that time, the cooling pad were not used in this system. Could you go to the next slide, please? So we have also some other case studies from other projects where we have used the soil system on cultivating eggplant. We have chosen the different variety of eggplant, and we were testing it compared to the commercialized one. And we have shown that the production of the eggplant was improved around like 60% to 70% compared to the regular cultivation methods in the soil system. And as you can see, like we have started to move to the automation in the soilless system by introducing advanced technology to this system. This project was done in 2005. It was funded by the early calls of the Prima project, and the result was extraordinary in terms of saving water. Then we have to start to move after the Syrian crisis happened, to teach the Syrian refugees about the soilless system, and the people were learning so fast, and they start to work in the farms located near the refugee camps. Could you move to the other slide, please? Okay, so here we have used different techniques in terms of the substrate itself. We also use the vertical farming, as Elisa explained. One of the vertical farming showed that the productivity or the yield increased 7 times compared to 1 square meter of using the soil alone. And also for some other project, we have used different varieties of plants like zucchini, cucumber, and also cherry tomato and tomato. But we can say that we have started to get into deep and rich experience with teaching also some people with the special needs about the simplicity of using the soilless system, and how it's important for a country that's facing challenges in terms of water scarcity and then some environmental problems. Next, please. Yeah, so here is some other example. We with the adaptation fund from some donors, we have moved to the local communities, start to introduce to them the idea of the soilless system. People start to grow on their top roof the soilless system. This is like learned fast, and they adopted this system fast, and they were happy about the results of their products, and they were like amazed by how this simple technique could be providing them with their special needs for vegetables to cover, or even like just like to help them with the food security issues. And also some of them, they started to generate income out of these practices. Next, please. And later on, we have moved to the advanced. We have combined the recirculated aquaponic system with the soilless system, where we have at NARC started the RAS system with the combined with the soilless system, where we are growing basil. We are conducting some experiments. We are playing with the density of the fish to see how they could affect the soilless system, and the result is different. We are about to publish the result out of this research. We have this system. When you are coming to NARC, you will see it. And we are also doing more and more on the added value crops. We do research on strawberry. We do research on some other herbs. And also, we are about to have like special training for farmers and for some other students from the colleges or universities. And again, there is like more challenges for every technology or every new method or a method that being adopted have like some challenges and has to be addressed. For instance, for the modern soilless system, the cooling issue is stagnant, and it's also increasing the prices unless like you are doing a massive production or on the industry or commercialized production. We have think about the solution. Some of the system were being using solar energy adapted or like connected to the off-grid solar energy to decrease the prices of the energy. As you all know, the closed area during the summertime, the temperature will be hot, and the greenhouses has to be cooled down. and we have adopted this kind of technology in some of the systems. To conclude, more research need to be done here at NARC and even worldwide, especially for the nutrient requirement for different crops to reach the optimization of the fertilizers that being used in the system. Also, we have to introduce more new ideas to think out of the box of the what we have reached to. We have to think about like more economical crops to increase the profitability for the farmers, and also we have to manage the diseases that could be generated for the soilless system. The highland area in Jordan is more suitable for hydroponic system. Again, as I said, because of the temperature variation, high variation of temperature. Now, the temperature in the Jordan Valley could reach today 47 to 50 degrees, while here in Amman we are sitting, which is around 38 degrees. And you can see like 10 degrees, that's a lot inside a trapped greenhouse. And it means we have to invest more and more, let's say, hybrid technology to cool down the greenhouses where we are locating our, let's say, soil system. Also, we have to think about a new substrates in terms if we want to reach to sustainability. It's whether material being recycled. We have to think about like creating a new material that could last for a generation. As you know, like the substrate could be degraded or depleted or even being as a waste. Finally, thank you everyone for listening, and I hope I have covered the experience that NARC has witnessed in the last like 25 years of implementing the soilless system.
Thank you very much, Amer. Sorry, I didn't show the conclusions. Thank you
That's
very
fine.
much. So I think we finished the very last thing, the homework, the exercise. So basically here I reported the different materials that we may need to construct a simplified substrate system. So my homework is to find the local cost of these materials to understand how much this system may cost in your country, and eventually if you can think about an alternative locally available substrate that may help to further reduce the cost of this system, or eventually be free, totally recycled. So I hope it is clear, and I think they can send the homework to Michael, correct, Michael?
I think Sala will write an email to everybody with the homework included again, and there she will also relay to her email address where to send it.
Perfect. Okay. Okay. And that's it. Thank you very much for your attention. And I don't know if there is time for questions, but I'm available.
I have a question, Elisa. On
Yeah.
slide 51, if you could go back.
Yes, 50.
You have a series of very interesting results.
Yeah.
Did you publish this somewhere?
Some of them are published, but I think we didn't have, let's say, an overview of all the data that we collected until now, a general overview, because we published something on the experience in Brazil, for instance. But in other cases, for instance, the application in Palestine and so on, we didn't publish anything. But we are working on that.
But if you have
Yeah, because the results are actually very interesting. And we
like your calculations, how like 5
yeah.
square meters of garden per adult, or like the water consumption data, or anything in this connection where you calculated this. Could you send me these publications? Because I would like to cite it? I'm just writing the review.
Absolutely. What I can send is a very interesting publication on rooftop agriculture using this simplified system in the city of Bologna. Something that it's a paper that explains how much space is needed in case of Bologna, in case of Italian population to have a self-production, and there are also data on water use efficiency, so I think it could be very useful, but everything I have I will share.
Okay, thank you. So I would like to invite everybody who is here to ask any questions to both Elisa and Amer about whatever we have seen. So Gertrude.
Yeah, I have a very little question first, because I saw on one of the slides of Amer that the women were wearing these high visibility vests in the greenhouse, and I just wonder why.
Yeah,
So maybe
so this is by the regulation. At some point, the donors for the vocational work has to wear special vest to identify them from the worker, let's say, or yeah. So this like showing the logo of the donors of the project, and also at some point this project was funded by the GIZ. So it's obligatory to wear these kind of vest for vocational purposes, and also let's say like you want to differentiate between the workers and also the trainee.
Okay,
Yeah.
interesting, very interesting. And the other question is, you know, now I have listened to more than, I mean, I have listened to a talk about the situation in Jordan more than once. And yours was again very revealing to me, because it looked, as an economist, we say that products should be produced where there are the comparative advantages to produce these products. And it looks like Jordan is really doing first thing. Second thing, of course, there is something like a national food security. A country wants to make certain that it can feed, at least to some degree, its citizens, its population. Now, from the presentations I heard, it seems that rain-fed or conventional farming is hardly possible, or only possible in few regions of Jordan. Just a second. Because of the noise. Just a second. And second, it seems that, you know, now intuitively, you would think, okay, then Jordan can do greenhouse farming, saving water, producing at least high value vegetables and fruits in greenhouses. But what you presented is that it is equally difficult due to the extreme temperatures in Jordan to use greenhouses, because then you need again energy to cool it down. And so I'm really a bit, let's say, clueless right now. What is the best way for Jordan to go?
Yeah, I mean, the Jordan Valley, the temperature is hot at the summer. Now there is like nothing being growing except for the date. Okay.
For the what?
So, the date palm.
Okay, the date palms.
Yeah.
So yes.
During the winter and also the spring, they're growing their products. I mean, the season starts with them in September and in May. This period where farmers can grow things in the Jordan Valley in the greenhouses. In the highland, you can grow all the season long. I mean, the temperature is this cooler, okay? But you're right. We have to think about like advanced method to cool the greenhouses, and I was suggesting that we have to adopt like off-grid solar energy system to cool down the greenhouses, or even like agrivoltaic being combined with the soilless farming. Shifting to the soilless farming, like it's not easy to convince the old mentality of farmers or the old-fashioned farmer to move from one way of farming to another way of farming. Things take time. It will take some preparation, training, infrastructure. I mean, for the large scale, I'm not talking about like household farmers. Even like thinking about like added value crops, which is very important to cover the high prices of the infrastructure that being to be implemented in the or adopted by the soilless system. It's you know, like again, we have to come to think about like the value chain analysis from zero, from the scratch to the final, let's say, purchasement of these vegetables or fruits or whatever.
May I ask one more question regarding water?
Yeah.
Groundwater or surface water, is that free of charge to farmers? And if you use water in
No.
greenhouses, for instance? Okay, so all the farmers pay for their water.
Yes, it's usually in the Jordan Valley, it's subsidized. In the highland, the price could reach 3 Jordanian dinar, which is 3.8 euro for 1 cubic meter.
Oh, that's a lot.
That's a lot, yeah.
Yeah, that's a lot. I think we in
The
Germany,
highland,
we pay less.
the highland, they are mainly using groundwater. They are abstracting groundwater, but in the Jordan Valley, it's mixed water with water from treated wastewater from the dams and also from the King Abdullah Canal.
Okay, thank you very much.
No problem.
I wanted to ask also, does Jordan has a problem with high salinity of soils also?
We do have problem in some places. The high salinity, it's coming from the, let's say, all the practices of of farming, the overusing of fertilizers, and also it could be coming from natural resources. Like you know, in the Jordan Valley, in the southern part of the Jordan Valley, there is an area where the salinity could reach very, very high. You have to do like soil remediation. Even the eastern part of Jordan, it's also generated from using salty water. You know, some water being used in the farms are being extremely salty, brackish water. The farmers in the eastern part of Jordan, they are using brackish water to irrigate their plant, and that will create a challenge for the soil, and you have to do like remediation. Some part of the Jordanian soil, it could considered like sodic soil. The pH could reach 8, and you have to treat it before you plant it, or unless you are using something soil tolerant crop to it.
Yes, because I suppose so, yeah. And this is also an element of an argument for using soilless.
Yeah, and also there is like some plants are like in love for the halophilic. It's called the halophilic. They are in love with the like let's say Siliconia or some other plant that they are in favor of a salty environments.
I have a question here in the chat. Ola wants to know the cost of groundwater in the highlands. Usually the water cost is very cheap, about 0.0 GOD. What is that? Jordanian dinar, I suppose. How is your currency called?
That's the price. That's the price for the owner of the well. But for the farmer, if you want to invest the infrastructure and getting the water from let's say a special well, especially in اليدودي area, or it could reach for 3 Jordanian dinar. And I have seen in my eyes invoices and price code for the bills that's for the farmer that are paying for the owner of the groundwater well. This the price 0.5 GD. It's the price that the owner of the well pay the government, but not the farmer paying for the owner of the well.
There is some business going on.
Yes,
there.
it is. It is. There's actually a new recent paper saying that there is a big business for. I can share the paper with you later on about this kind of business, which is a black market.
Okay. Gertrude has another question.
Yeah, first thing, maybe when Sala is sending out the homework, she could also send out the paper by Elisa and what Amer just mentioned.
Yeah,
Yes.
sure.
Yeah. And my question is maybe, yeah, it's a question and let's say an idea, because it seems that since it is hot in Jordan with a lot of sun, the potential for solar power is high, and therefore there is a lot of power. There would be a lot of power for cooling down a greenhouse. So my question goes to Elisa and Amer. Are there is there something like optimizing greenhouses such that the rooftop or the energy you use, you know, that you optimize the greenhouse in such a way that the solar energy to be generated is exactly fitting the needs of a certain size of a greenhouse, so that you produce always enough energy to cool down to cool the greenhouse down. Is there something like that? Because that could be I mean, it seems like this would be ideal for Jordan.
It's a thermodynamic issue. It's
Yeah, exactly.
how much you want to cool, how much you will use energy, and also you have to operate at some point 12 hours of a grid system. It means that you have to invest also in a battery for during the night, and it is a bit costly, but we have to think about, like, let's say the optimization need to be focused on combining added value crop in the soilless system if we want to go that deep into the saving energy issues, even in the Jordan Valley.
Also, can I say something?
Yeah, sure.
Also, focusing on Amer's words, this is a lot of cost, and you know, big farms and some projects here invest in this technology. We have a project called Sahara in near Aqaba, which is also of high temperature, and they do desalination of seawater, and they use cooling of the roof. But this is a big project, a big investment by their government. And also they plant an added value crops and sell it directly to Norway. I think it is a Norway a company, a Norway project, and they are investing in this project in Jordan. And it is in literature or in Google, you can find it. It is called Sahara. Sahara in Arabic means desert. So they are working there using this cooling level.
Anything else?
Are there any more questions? If not, we will stop, conclude the seminar, and again, for those who came later, for the second cycle of the seminar, which starts on the August 22, you need to re-register, and we will be also to the all participants of the first cycle, we will be sending the links, and you need to re-register, and then you will get a new link for the event. So thank you very much to everybody, to the presenters and discussion, and see you in August.
Thank you, Ranka.
Thank you very much. See you.
Bye-bye.
Bye
Thank you,
bye.
everyone.
Bye.
Bye.
Bye-bye.
Breakout rooms? No. Oh, Michael.